All right, welcome back. Happy Friday. I saved what we did the last time, and I'm just going to start from that same exact point. Your problem was sine x plus 2 equals 3. I'm not going to go through every step, but you should have gotten sine x equals 1. Okay? If you were looking like I am in the back of your classroom and all the graphs, you would have found that x, the only time sine equals 1, was at 90 degrees. And that would have been your only answer. I hope you got that one. I hope we've talked about it since I gave it to you. So, great job. That one I probably would have plugged in my calculator. It should have given me 90 degrees, just like that. All right, we're moving on to more of 6.2. Okay, can we solve by factoring? Okay, solve by factoring. We're going to start out by easy factoring, but you may have to remember, may have to go watch some Khan Academy on how to factor. Okay, and that's okay. Maybe I'll even assign some problems that are factoring, just so that you can remember from Algebra 2. Okay, so if we have a problem that we want to solve by factoring, can you solve sine theta times tangent theta equals sine theta over the interval from 0 degrees to 360 degrees. Okay? And in a little bit, we're going to change that interval too. Because what if it was pi's? That's the only thing we would change it to. We would change it either from 0 degrees to 360 or 0 radians to 2 pi radians. All right. Now, there's a huge caution box right below this problem because it says, I'm going to read it to you. If you try to solve the equation by dividing each side by sine, it would just lead to tan theta equals 1. Okay? But if tan theta equals 1, sine equals sine, and theta could be anything. Okay? So, the other two solutions would not appear. The missing solutions are the ones that make the divisor sine equal to 0. All right, so here we go. So what we are not going to do is divide by sine. So how could we solve for theta in this circumstance? Well, I'm going to show you one thing. When we are factoring, generally you always want 0 on one side. Okay, because there's no numbers in this, so we have to get all the thetas together. Okay, so we're going to start by subtracting sine theta from both sides. Okay, sine theta minus sine theta is 0. But sine theta, tan theta minus sine theta, you can't simplify at all yet. Sine theta, tan theta minus sine theta. When you're subtracting it, it can't just come out. Okay? But now, does everyone see that there are two terms? One term, two terms. Is there anything common in both terms? No, I heard you all say there's a sine theta in both terms. Could we factor it out? Okay, I know you're probably ready for a thought bubble. Okay, if we have 8x minus 2. If we factor out a 2 from this term, we divide 8x divided by 2 is 4x. 2 divided by 2 is 1. Okay, so that's how we would factor out that 2. So when we factor out a sine, we've divided by sine. From this term, what's left? Tan theta. What's left with this term right here that was just a sine? Sine divided by sine is 1. Please don't forget that 1. It's very important. Okay? Now, if you have something, I'm going back to my thought bubble again. If you have something that looks like x times 2x minus 1. Okay? And we have that equal to 0. How do you solve for x? Well, you have two different pieces, and each piece could equal 0, and this be a true statement. Okay? So x could equal 0. In this case, I would take this x and say, hey, x could equal 0, and this be true. Okay? Or we would say 2x minus 1 equals 0. We would add 1. And we would say 2x equals 1. So x could equal a half, and this still be true. Because if x equaled a half, we would say 2 times a half is 1. 1 minus 1 is 0. A half times 0 is still 0. Okay? So do we see our two separate pieces that we have to set equal to 0? Yes. So we're going to look at this and say sine theta could equal 0. Or tan theta minus 1 could equal 0. So solving, keeping going down to find theta. Theta is sine negative 1 or inverse sine of 0. Okay, this one we need to do a little bit more. We need to add 1 to both sides. So tan theta equals 1. So we would say theta equals inverse tan of 1. Okay, I'm going to scroll down. Well, you remember we're going from 0 to 360. Okay, so I'll try not to scroll too much. For sine, let me look at this one first. It's kind of the same color, sorry. I'm looking at my graph. You did a graph last week over from 6.1 of sine theta, right? So you should have your graph somewhere in your notes of sine theta from negative 2 pi to positive 2 pi. So you've got the 0 to 360 in that graph. And when you're looking at sine and you're finding zeros, I see a 0 at 0 degrees. I see a 0 at 180. I see another 0 at 360 degrees. Okay? If you plug in your calculator, you're only going to get one of those. You have to remember these graphs or have one somewhere around you. Okay? So, over the interval, equals to 0, not equal to 360. So I said 3 answers, but I can't give 3 answers. It can be 0 degrees or it can be 180 degrees. Okay, it will not be 360 even though sine of 360 is 0. This parenthesis says I'm not equaling 360. Okay, well let's look at tangent. Let's figure out tangent. Opposite over adjacent is 1, or I can plug this in my calculator. I like a triangle. The opposite and the adjacent are 1. What type of triangle do we have? 45 degrees. My reference angle for tangent. Okay? So, again, I need to look, where is tangent positive? 2 things from yesterday. We found our reference angle, and we found out where tangent was negative. I'm going to redraw that. Sorry. I'm going to draw it so that we can see colors. So tangent is positive in the first quadrant and in the third quadrant. My reference angle is 45 degrees in both. Okay, so right here in the first quadrant, the answer is 45 degrees. Theta could equal 45 degrees. Or in the third quadrant, looking back at my plate at this reference angle of 45 degrees, and I get 225 degrees. Okay, so angle in the first quadrant was 45. In the third quadrant, it's 225 degrees. So your theta can equal any of these 4 pieces. Any of these 4 degrees. It could be 0, it could be 225, it could be 180, or it could be 45. We could check that in our calculator if we plugged in sine of 0 degrees. Sine 0 is going to be 0. 0 times tangent 0, still 0. does that equal sine of 0, which is 0. 0 equals 0. Check. It works. Okay? All right. It's time for you to do another one. Us to do another one. That, again, was probably a lot. Let's do, it's going to be another one. Here we go. Cosine theta times cotangent theta equals negative cosine theta. And this time we're going to go over the interval of 0 to 2 pi. Okay, I'm changing up the interval. Just means your answers will now be in radians. Okay, your interval will tell you the answers, or need to be. They will need to be in radian. The pies. It's going to show up on your plate. It's okay. At least, yeah. I don't think I ever give you one where it doesn't end on your plate on a radian. Degrees, I might. We'll do one of those in a little bit. So, if you've got that example written down, we're going to start this one the exact same way. Okay? We're going to take our equation. This time, instead of subtracting, what do we need to do? We need to add cosine theta, because this has to be 0. Okay? So we're going to add cosine theta to both sides. We're going to get cosine theta times cotangent theta plus cosine theta equals 0. Okay? We're going to factor out what is the same in each term of our problem. You're right, there's a cosine theta, the same in each one. Okay? Every time you factor, you should be able to check it. How would we check that? Well, cosine times cotangent gives me cosine cotangent. Cosine times 1 gives me cosine. You can always check your work that way. We'll take those two lines away because we've done that. Now we're going to set each piece equal to 0. So we're going to say cosine theta equals 0, or cotangent theta plus 1 equals 0. Okay, so here solving for theta, theta equals the inverse cosine of 0. Over here I've got to go a little bit more. I've got to subtract 1. So cotangent theta equals negative 1. Okay? Or sometimes at this point, because it's not one of my first 3, I might do a switcheroo. I'm going to find the reciprocal. Okay? What's the reciprocal of cotangent? Yeah, we might need the back of our plate. The reciprocal function is tangent. So when I flip cotangent to be tangent, I would take the reciprocal of negative 1. What's the reciprocal of negative 1? That's right. It's 1 over 1, which becomes 1 over 1. Okay? So I'm going to find the reciprocal function in this case. So tan theta would equal negative 1. So theta would equal inverse tangent of negative 1. Now, here we go solving. Cosine theta, you can plug in your calculator. It'll give you one answer. You have to look at your graph. You have to know that cosine is going to equal 0 at more than one place. Okay? Maybe I'll post a picture of these graphs somewhere. Maybe. Right now, you should keep that. Keep those graphs of negative 2 pi to 2 pi. You did those on your paper. Keep those notes. I did them in the screen recording, so you know you have it correct. Keep those, okay? So where in the world is cosine theta equal to 0? I'm looking at the graph, and I can see it's 90 degrees and 180 degrees. Yes, theta equals 90 degrees. Wait. Am I putting degrees? No, we are putting radians, so I'm looking at my plate. 90 degrees is also pi over 2. And, sorry, I said 180, didn't I? It's not. It's 90 and 270 degrees. It's on the y-axis. So instead of 270 degrees, I see it's 3 pi over 2. And those are my two answers for theta, and cosine theta equals 0. Okay? Your calculator would give you one answer. It would give you a 90 degrees. Okay? That's your reference angle. Over here, it seems like we just did one that was a 1. Tangent theta equals 1. Which triangle am I using? The opposite and adjacent are 1. We'll look at the negative in a minute. That's right. This is a 45, 90 degree triangle, where 45 degrees is my reference angle. Okay? 45 degrees is my reference angle. Will that be one of my answers? No, because we need to know, where is it? Negative. Okay, so which quadrant is tangent negative? Yeah, second quadrant and fourth quadrant. So I'm going to look reference angle, second quadrant, reference angle, in the fourth quadrant. I'm looking at my plate. I'm looking at 45 degrees in the second quadrant. And I know this theta is 135 degrees, but in radians it is 3 pi over 4. That's right here. I'll write 135 or 3 pi over 4. In the fourth quadrant, reference angle is 315 degrees, or 7 pi over 4. So we have 4 answers for this problem. Would I require all 4 answers? Yes, I would. Okay? So now we're going to slow down, and I'm going to give you a problem to solve. Okay? Let's see. Oh, that one they already factor for you. They don't give you another really good one. Maybe we'll do this one together. 10 squared x plus 3 equals 4. What if we did that one? We'll probably do that one. Okay, and I want you to go over the interval from 0 to 2 pi. Okay, that's your problem number 1. Then we're going to have a second problem that they already factor for you, which is okay. It will help you to solve take each piece and set equal to 0 in that case. Okay. One thing that I will tell you, this is going to have the same interval. 0 to 2 pi. One thing that you do have to remember, little hint, remember, when you take the square root, I'm just going to write a random number, the square root of 9. What is the square root of 9? You all said 3, probably. But I'm going to ask you, is that totally correct? The only thing times itself to give me 9 would be 3. What about negative 3? Is negative 3 times negative 3 equal to 9? Yeah, so when you take the square root of something, don't forget your plus or minus. When you're doing tangent, right here, and you get a tangent squared equals something, when you take the square root, don't forget to put the plus or the minus on the other side. All right, good luck. You've got this. Let's talk during the day today. And don't forget to like, comment, or subscribe. Bye, guys. Happy weekend.